In section 2.2, we're going to be solving inequalities by adding or subtracting. So we've got 4 warm-up problems, 2 of which deal with graphing an inequality based on the situation, and 2 in which we are just simply solving a one-step variable equation. All right, so here are our solutions. So number 1 says the temperature must be at least negative 10 degrees Fahrenheit. So that would mean negative 10 degrees or more. So closed circle on negative 10 shaded to the right. So T is greater than or equal to negative 10. Number 2 says the temperature must be no more than 90 degrees Fahrenheit. So T is our temperature again, but it needs to be 90 or less. So closed circle on 90 shaded to the left. So T is less than or equal to 90. In number 3, we're solving, so in order to isolate x on the left-hand side, we add 4 to both sides, so x is equal to 14. And in number 4, in order to isolate x on the right, we would subtract 1.1 from both sides, so x equals 13.9. So our goals for today are to be able to solve one-step inequalities using both addition and subtraction. And we actually did 1 or 2 of these in yesterday's or the previous lesson in section 2.1. So we're going to solve our inequalities just like we solved equations using inverse operations in order to isolate our variable. Okay, so there's our big idea. It's going to be to continue to isolate the variable using inverse operations. And we're going to call these algebraic properties of inequality rather than equality because we're dealing with inequalities. So what does that mean? So for example 1, if we want to solve x plus 12 is less than 20, I'm going to circle my variable, dotted line through the equal sign, and then in order to get x alone, we would subtract 12 from both sides. So in this case, this would be considered the subtraction property of inequality. So we're still keeping our inequality the same by doing the same thing to both the left and the right. So we're ultimately going to get x is less than 8. So there's our solution. We're going to locate our target number 8 on the number line. I know it's tiny. It's going to be an open circle, and we're going to shade to the left. Okay, so let's pick a number such as 0 as a test point. If I use 0 and plug it into my original problem, 0 plus 12 is 12, and 12 is less than 20, so that's good. It doesn't guarantee us that our target number is correct, but it means that some of the shading is. So let's check number 2. D minus 5 is greater than negative 7. Dotted line through my inequality, circle my variable, and now I'm going to get D alone on the left by adding 5 to both sides. So that leaves us with D is greater than negative 7 plus 5 is negative 2. So we're going to locate our target number of negative 2 on our number line, and we are going to shade to the right. Okay, let's once again pick a number just to kind of check our shading. And I like to use 0 as a test point whenever I can, just because it's easy to plug in. So 0 minus 5 is negative 5, and negative 5 is bigger than negative 7, so that works. All right, number 3. Number 3, we're going to continue to solve just like we would. Circle our n, and this time we're going to isolate our variable on the right where it's currently located. So in order to do that, we are going to add 0.3 to both sides. Okay, so we're going to keep everything in line where it is. So we're going to get 1.2 is greater than or equal to n. Now we need to make sure, especially with inequalities, that we then write our answer with the variable first. So we're going to flip the whole thing around, meaning we're going to put our variable on the left, we're going to put our 1.2 on the right, and we need to make sure that we leave our inequality open to the same term or number that it was open to before. So it was open to the 1.2, so it needs to remain open to the 1.2. So if 1.2 is greater than or equal to n, it would therefore mean that n is less than or equal to 1.2. Okay, so we want to make sure that we always flip our whole answer all the way around and that we can then verbally describe it a little easier. So we're going to locate approximately 1.2 on our number line. It's going to get a closed circle. Let me see if I can zoom in here a little bit. So we've got 1.2 on the number line. All the other number lines are pink, so I'll keep it that way. It's going to be a closed circle, and we're shading based off of our final answer here because that's when the variable was first. So as long as the variable is first, shade in the direction the inequality points. All right, so n is less than or equal to 1.2. So let's go ahead and check. Let's pick a test point. If we plug in 0, 0.9 is greater than or equal to 0 minus 0.3. So is 0.9 greater than or equal to negative 0.3? Yes, it is. Okay, let's move on to number 4, and I would like you to, I think we're capable of doing 4, 5, and 6 independently. You just have to be careful with number 5, because in number 5, you're going to be getting your variable t by itself on the right. So we're going to have to make sure we flip our whole problem around, our whole answer around, like in number 3. All right, so take a second and check your work. Number 4, we have s is less than or equal to 9. So 9 is our target number, closed circle, shaded to the left. Number 5, we ended up with 5.5 is greater than t, which means that t is less than 5.5. So target number is 5.5, halfway between 5 and 6, shade to the left. And actually, I wasn't paying attention when I was doing this. That needs to be an open circle at 5.5. These number lines are so extremely tiny so that I could fit everything on a couple pages here. So open circle at 5.5, shaded to the left. All right, and then for number 6, when we get q by itself on the left-hand side, we have q is less than 11, so we needed to go up to 11 here on the number line, open circle, and shade to the left. Okay, so this is more or less a combination of Chapter 1 and what we did in Section 2.1. So all of our inequalities we're going to represent with a mathematical statement here, an inequality, and then also on a number line with our open versus closed circle and shading to the left or right. All right, so let's take a look. Since there can be an infinite number of solutions to an inequality, it is not possible to check all the solutions. You can check the endpoint and the direction of the inequality. So that's kind of what we did before. So just picking a number within our shaded region will help us to determine, to make sure that our shading was correct. And we can test the endpoint itself as if we were going to plug it into an equation. And what I mean by that is if I check number 1 and I put in 8 for x, let's just pretend it's an equal sign. So 8 plus 12, does it equal 20? So yes, 20 equals 20 would be a check in terms of verifying that your endpoint or your target number is in fact correct. All right, so let's take a look at a couple word problems here to wrap up. Says number 7 says Sammy has a gift card. She's already used $14 of the total value, which was $30. Okay, so she's used 14 the original value was 30. Write, solve, and graph an inequality to show how much more she can spend. So her spending can be no more than $30 because she has a set amount of $30 in or on her gift card. So I'm going to start with my words first. So total spent can be no more than 30, so can be less than or equal to $30. Now she already spent some money, so that's going to go in the spent side. And we don't know how much she has left, so that's going to be our unknown. That's going to be our variable. So she's spent $14, and she has an unknown amount yet left to spend, and then that still needs to be less than or equal to 30. So here is our inequality that represents the situation where we're going to say let X equal amount left to spend. All right, so we're going to go ahead and we're going to solve this inequality by simply subtracting 14 from both sides. So we've got X is less than or equal to 16. So here is the inequality, how we can write the solution. So X is less than or equal to 16, and now let's verbalize it. Sammy can spend up to $16 additional dollars. And that's kind of the way I verbalized it versus writing it sounds kind of funny. Sammy can spend up to $16 more. On her gift card. Okay, so she can spend $16. So it's up to. She could spend $10. She could spend $2. She could spend no dollars if she wanted to, and she'd still have $16 remaining. Let's take a look at number 8. The recommended daily allowance of iron for a female in Sarah's age group from 14 to 18 years old is 15 milligrams per day. She has consumed 11 milligrams of iron today. Write and solve an inequality to show how many more milligrams of iron Sarah can consume without exceeding or going over the recommended daily allowance. So that's going to be very similar to our last situation. So the total iron that she can consume per day without exceeding the recommendation. So her total iron needs to be less than or equal to 15 because we don't want to exceed it. So she can meet it but not exceed it, not go past it. So currently she has already consumed 11 milligrams, so that's going to go in her total count. And then we're going to add our unknown, the remaining amount, and it needs to be less than or equal to that 15. Now, I know many of you can do this just mentally in your head and figure out the answer, but that's not the point. The point here is to start writing these words first, start writing these basic inequalities while it is basic, while it is easy, because it's going to get more difficult. And if you don't do the correct steps or the correct process now, it's going to come back and get you later on. Okay, so that's why this is important, and we need to write everything down. So our variable X here is the amount of iron left to consume. All right, so let's again circle our variable, dotted line through our inequality. We're going to subtract 11 from both sides. So X is less than or equal to 4 milligrams. Okay, so let's write our answer as an inequality. So X is less than or equal to 4, and it means that Sarah can consume up to 4 more milligrams of iron today. So Sarah can consume up to 4 more milligrams of iron today without exceeding the RDA. All right. So I would like you to go ahead and give number 9 a whirl. It says Mrs. Lawrence wants to buy an antique bracelet at an auction. She's willing to bid no more than $550. So far, the highest bid is $475. Write and solve an inequality to determine the amount Mrs. Lawrence can add to the bid. So number 9 is going to be set up and solved exactly like numbers 7 and 8. All right, so here is our solution for number 9. The total bid is going to be less than or equal to $550 because she's willing to bid no more than $550. So up to, but not including, or up to and including $550, but not more than that. So currently the bid is $475. We need to figure out how much extra she can add to it and still be less than or equal to that $550 threshold. So when we subtract $475 from both sides, we get X is less than or equal to 75. So Mrs. Lawrence can add up to $75 to the current bid. Or you could also phrase it $75 or less. All right, and last but not least for this particular lesson is number 10, and number 10 is going to be a greater than situation. So our first 3 word problems were all less than, and actually less than or equal to. Number 10 says that Josh wants to try to break the school bench press record of 282 pounds. So to break a record, you need to bench more than that 282 pounds. Okay, so he wants to break the school bench press record. That is 282 pounds. He currently can bench 250. Write and solve an inequality to determine how many more pounds Josh needs to lift to break the school record. So we're going to still follow the same general principles as we did in 7, 8, and 9, but now we just have to use a different inequality symbol. So the total weight that Josh lifts needs to be greater than 282. Are we going to put an or equal to sign there? I'm going to go with no. We're not going to put an or equal to sign there because you're not breaking the record if you lift 282 pounds. You're tying it. So our total weight that Josh lifts needs to be greater than 282 pounds. So he currently is bench pressing 250 pounds. We need to figure out how much he needs to add to his bench press in order to break the record. So we'll call that X and finish writing out our original inequality. So our let statement defining the variable is let X equal weight. I should actually probably write additional weight needed. To break the record. Okay, so we're going to solve this. Dotted line through our inequality, circle the variable. When we subtract 250 from both sides, we're going to end up with X is greater than 32. Now, if we're just talking basic inequalities, that's our literal solution. But, I mean, this is a real life situation. So we can write it a couple different ways. And obviously, I don't know that much about bench pressing records. So technically, 32.1 pounds would do it. But I don't think that they do weight in increments other than at least a pound. So let's start by saying Josh must lift more than 32 additional pounds to break the record. So if we start to think about what that means is, okay, again, not knowing much about weightlifting, that would imply he needs to lift 33 pounds or more, okay, because again, 32 pounds isn't going to do it, and I doubt that they're going to add a feather or add 0.1 pound or 0.0001 pounds in order to clearly break the record. So just kind of start thinking about our inequality solutions in a way that is a little bit more logical in how you would actually describe it. Okay, so more than 32 additional pounds is a very, very good way to describe it. But again, it could also be more or less discussed as, okay, he's got to lift 33 or more additional pounds on top of that 250 that he's already benching.